Hi everyone, my name is Daniela Galárraga-Espinosa and I'm a PhD student at the Institut d'Astrophysique Spatiale in Orsay, France. My work focuses on the study of cosmic filaments, and I use numerical simulations in order to better understand the distribution of galaxies around them and also the properties of gas in these structures. So in my first paper, I found that galaxies are not distributed in the same way around filaments of different lengths. This led me to the identification of two populations of filaments, so the short filaments, which may be seen as the bridges of matter between overdense structures. They are tracers of the denser environments, and on the other hand, the long filaments that are more like the cosmic filaments that shape the large scales of the cosmic web, and they are tracers of the less dense environments. I also modeled the galaxy density profiles around the different populations of filaments, and I use different models that I found in the literature in order to better and to further understand the distribution of galaxies around the filaments. Then I focused on the gas properties around the filaments, and I separated gas into different phases, which I studied, like the temperature, the pressure, and the distribution around different populations of filaments. So here you can see an overview of my results. So far away from the filaments, gas is mostly in the diffuse phase, and as we approach the core and the spine of the filament, gas is accreted towards it, and the diffuse phase is converted into WIM. WIM is the most dominant phase at 1 megaparsec from the spine, and the core of the filament has several properties that are very interesting. Temperature is it's dependent on the length of the filament, on the population. It's an isothermal core, and I also characterize the pressure of this of the core of filaments. In order to get closer to observations, I computed predictions of the Sunayev-Seldovich effect, and I compared that with recent observations, which I found a good agreement between my predictions from the simulations and the results. So yes, if you're interested in my work, you can send me an email or just click into my work. And yeah, thank you.